Myself, P. Reddy Prasad, Associate Professor, Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Now I am going to discuss Engineering Chemistry Module 1, Electrochemistry and Corrosion. So now I am going to cover the topic in this Module 1, Electromotive Force, Electrode Potentials and Electrochemical Series. So what are the contents? These are the important, I am going to discuss, these are the important contents in the presentation. Electromotive force, electrode potential, electrochemical series. So let's start the content. Electromotive force. Electromotive force is nothing but the flow of electrons from one electrode to another electrode, and due to the results of this flow of current, the flow of electron, so the electrode, the current flow from higher potential to lower potential. It is called as a electromotive force. Due to the reason of the electrons flow from anode to cathode, so the potential will be generated. The potential difference, the higher potential to lower potential difference, we are called as a electromotive force. Electromotive force is nothing but EMF of this cell. Electromotive force is nothing but EMF of this cell. So what is the EMF of this cell? EMF of this cell is equal to the potential difference in between the two electrochemical cells. We know that is a voltaic cell is having two off cells. Voltaic cell is having two off cells. So one off cell having zinc electrode and zinc sulfate solution, and another electrode is having another cell is having copper electrode and copper sulfate solution. This is the copper sulfate solution and copper electrode. This is the zinc and zinc sulfate solution, zinc electrode. These two electrodes were connected with voltmeter, and salt bridge is also required to complete the electrochemical circuit. So now the potential is generated from anode to electrons will move to anode to cathode due to the reason the oxidation and reduction takes place in the electrochemical cell. So when oxidation takes place, the potential is generated in the electrode. So that electrode, the potential difference in between the two off cells, we are called as a electromotive force. In the electrochemical cell, the potential difference is generated in between the two off cells. That potential difference is called as a electromotive force. Electromotive force is also nothing but EMF of the cell. So EMF of the cell, the reduction potential of right hand side cell electrode minus the reduction potential of left hand side electrode. The EMF of the cell, we simply represented this equation, the reduction potential of right hand side electrode and the reduction potential of left hand side electrode. We know that left hand side electrode, right hand side electrode. Right hand side electrode is the oxidation electrode, anode electrode is present. And the left side is anode electrode is present, and right side is cathode electrode is present. So the EMF, the reaction, we are called, there is a simple equation. So E reduction or E cathode minus E oxidation or E anode. We also simplified that equation. The EMF equal to E reduction or cathode. It means at the reduction, it takes place at the cathode. So that's why the cathode electrode potential. The E cathode is represented by E electrode of cathode, and E anode, it means, so at anode oxidation takes place. So that's the reason we are called as that is anode electrode. So cathode electrode minus anode electrode, potential difference is called as a EMF, electromotive force of the cell, electromotive force of the electrochemical cell. So we are going to simplify this equation very simply. The EMF of the cell equal to E anode plus E cathode. Also we can represent the same equation, E anode plus E cathode or E cathode minus E anode. The potential difference in between the two electrochemical cells, it is called as the electromotive force. The electromotive force is always equal to, so it is very equal to the potential of cell. That's why we are called as a cell potential also. So the cell potential is very close to near to the value of electromotive force. The EMF of the cell, so that is a simple, there is any electrochemical cell having two off cells. The right hand side of the electrode and the left hand side of the electrode potential difference we are represented by EMF of the cell. We simplified that cell representation. EMF of the cell equal to the cathode electrode minus the potential of cathode electrode minus the potential of anode. Then also we can write that same equation. The electromotive force of the cell equal to E anode plus E cathode. The electromotive force equal to E anode plus E cathode. We can see that one simple problem on this electromotive force for understanding. If there is a simple problem is this, simple calculation to calculate the EMF of the cell. So there is a off cell reaction for the zinc and zinc sulfate and copper sulfate and copper. This is the electrochemical cell, voltaic cell. They are given the standard EMF of the cell. Standard EMF of the cell they are given. The standard EMF of the cell we are represented E naught. The standard EMF of the cell we are represented E naught. Standard means at standard parameters, when we are going to calculate the potential difference, that potential difference in the electrochemical cell is called as a electromotive force. At 25 degrees centigrade, at 1 atmosphere pressure and 1 molar concentration, we are going to calculate the potential difference. We are going to measure the potential in the electrochemical cell. That potential is called as a standard EMF of the cell or standard electrode potential. The standard EMF of the cell, they are given the E naught of zinc electrode, that is minus 0.76 volts. The E naught value of copper electrode, that is the value plus 0.34 volts. They are given the oxidation potential value and reduction potential value. So E naught standard electrode potential value E naught, the standard electrode potential value E naught, zinc 2 plus and zinc, it means the zinc 2 plus to gain the electrons to convert it to zinc. So they gain the electrons. Due to the gain of electrons, the potential is generated there. That potential is standard electrode potential, that is 0.76 volts, minus 0.76 volts. And usually the copper standard reduction potential, I mean copper Cu2 plus or Cu. The Cu2 plus means Cu2 plus to gain the electrons is converted to Cu. The potential is plus 0.34 volts they are given. Now what is the EMF of this cell? They are asking what is the EMF of the cell. Calculate the standard EMF of the cell. Standard EMF of the cell, E naught EMF of the cell, I mean E naught EMF of the cell, EMF of the cell equal to E cathode, E naught cathode minus E naught anode E cathode value is a plus 0.34 volts minus, and E naught potential value minus 0.76 volts. So plus minus, we are getting 1.10 volts. This 1.10 volts, so the EMF of the potential of that particular electrochemical cell. So in the EMF, for understanding of EMF, the potential difference in between the two electrodes we are called as a EMF the cell. The potential difference in between the two cells, two off cells, we are called as a EMF of the cell. So that EMF of the cell at standard condition, if you measure, at standard condition means at 25 degrees centigrade, at 1 atmosphere pressure and 25 degrees centigrade, 1 atmosphere pressure, and we are measuring the potential. That potential is called as a standard EMF of the cell. The standard EMF of the cell, simply we are writing E cathode, E naught cathode minus E naught anode. The standard EMF of the cell, also we can measure using the same formula, E naught EMF equal to E naught reduction potential minus E naught oxidation potential. E naught cathode minus E naught anode, or we can simplify this equation, the standard EMF of the cell equal to E naught anode plus E naught cathode. This is the electromotive force. So now we are going to discuss what is electrode potential. What is electrode potential? Electrode potential, when metal is placed in a solution of its ionic solution, so that is electrolyte solution, the metal acquires either positive or a negative charge. So when the respective electrode we are immersed in the own solution, the potential is a difference. The potential is developed in between the metal and electrolyte solution. The potential is developed in between the metal and electrolyte solution. Thus, potential difference is called as a electrode potential. So that electrode potential is nothing but when we are taking the metallic electrode is immersed in, that metal is immersed in own electrolytic solution, then due to the reason of the positive or negative charge of the ions to move the specific particular metal electrode, that then due to the reason, so the potential is developed in between the metal and the solution. For example, if you take, this is the off cell. In the off cell, we are taking one electrode. That electrode we are dipped in the electrolytic solution. Then, due to the reason of the concentration between that electrode and electrolyte solution, the potential is generated due to the reason of oxidation and reduction reaction, due to the spontaneous reaction. That potential is called as a electrode potential. The potential difference is called as a electrode potential. So in the electrode potential, we can say that the terminology oxidation, what is oxidation and reduction potential? If the electrode is, anode electrode is there, that metal, it is anode, that means it is a zinc. For example, in electrochemicals and in voltaic cell, we are taking the zinc. So that electrode is the zinc, anode, that zinc is act as an anode. It means oxidation takes place in the electrolyte solution. The oxidation takes place means the zinc is going to zinc 2 plus and 2 electrons. To remove the electrons, to lose the electrons. Where the electrons will be lost at the electrode, that electrode it is called as a anode electrode. That potential, due to the reason of oxidation, the potential is generated in the electrode, cell, off cell. That potential is called as a oxidation potential. If you take same copper electrode in the voltaic cell, the copper electrode we are going to immerse in the own copper sulfate solution. Then the copper sulfate solution to gain the electrons Cu2 plus, to gain the electrons Cu2 plus, to gain the electrons to convert it to copper solid. This is the reduction. So due to the reason of reduction reaction takes place at the electrode, the potential is generated at copper 2 and copper sulfate solution. So electrode, in between the electrode and electrolyte solution, the potential is generated due to the reason of reduction potential. That potential is called as a reduction potential. So electrode potential, maybe that is oxidation potential or reduction potential. If oxidation reaction takes place, then we can say that is oxidation potential. If a reduction reaction takes place, that is called as a reduction potential. Always oxidation potential is equal to minus reduction potential. Always oxidation potential is equal to minus reduction potential. This is very important for understanding electromotive force also. If you look at the zinc electrode, the standard oxidation potential is, we are represented, see that there is a standard electrode potential. E0 means standard potential. The standard oxidation potential means the zinc is going to zinc 2 plus to release the electrons. The zinc to release the electrons, lost the electrons. When lost the electrons is converted to zinc 2 plus. This is the oxidation reaction. So simply we are writing that the zinc electrode, zinc and zinc 2 plus. The potential is 0.76 volts. 0.76. This is the oxidation potential of zinc electrode. If a the reduction potential of zinc, the same standard condition, 1 atmosphere pressure, 1 molar concentration, 1 atmosphere pressure and 1 molar concentration and 25 degrees centigrade. So the reduction potential of zinc, if the same, the zinc to gain the electrons, zinc 2 plus to gain the electrons to convert it to zinc solid. This is the reduction. So due to the reduction, zinc 2 plus is converted to zinc solid. Due to the reduction, the potential is minus 0.76 volts. So that is the reason the oxidation potential always minus reduction potential. So the oxidation potential of zinc electrode is 0.76 volts. The reduction potential of zinc electrode is minus 0.76 volts. Minus 0.76 volt. This is the electrode potential. Electrode potential. The electrode potential we can distinguish either oxidation potential and reduction potential. If oxidation takes place, we can call it the oxidation potential. So the reduction takes place, we can call it that is a reduction potential. Oxidation means loss of electrons. If a loss of electrons, the electrons will be lost at the electrode, that is the anode electrode. If electrons to gain, atom to gain the electrons at the electrode, that electrode is act as a cathode electrode. Then we know that standard electrode potential. For understanding another one, what is standard electrode potential? We know that the potential difference in between the metal electrode and the solution. So electrode and electrolytic solution, that is called as a potential, that is called as a electrode potential. So electrode and electrolyte solution potential difference is called as electrode potential. So at standard condition, 25 degrees centigrade, that means 298.1 kelvins at pressure 1 atmosphere pressure, and the concentration of the electrolyte is 1 molar concentration, we are called as a standard electrode potential. And standard condition, the developed potential in between the electrode and the electrolyte solution. We know that off cell, there is a off cell. So one electrode is present. We immerse in that electrode the same electrolyte solution. For example, this is the zinc and this is the zinc sulfate electrolyte solution. So the electrolyte solution and the zinc electrode, so there is a potential difference is generated. That potential difference we are going to measure at 25 degrees centigrade and 1 atmosphere pressure and 1 molar concentration, 1 unit molar concentration. So that potential is standard electrode potential. At the same condition, if you measure the potential at cathode, that potential is standard reduction potential. The potential of the reduction under standard condition, the same condition, 1 atmosphere pressure and 1 molar concentration of electrolyte and 25 degrees centigrade. So the reduction potential will be generated at the cathode. That potential is standard reduction potential. The same like that, similarly, we can say that standard oxidation potential. Oxidation potential means the same. So where the oxidation takes place at the electrode, so that potential will be generated at the electrolyte solution and electrode at standard condition. That potential is standard oxidation potential. So at standard condition, when we are going to measure the potential, we can say that that is the standard electrode potentials. If a standard condition, if you go for measure the voltaic cell potential, that is standard voltaic cell potential. In standard condition, we are going to measure. So oxidation potential and reduction potential. So the standard condition, so the cell potential of voltaic cell is so 1.1 volts, 1.10 volts. And what is the advantage of standard electrode potentials? Why we need to measure the potentials at standard condition? We know that the first advantage is we will know that the strength of the various oxidants and reductants. If there is a possibility to relative strength of, so which is act as a strong oxidant, which is act as which element is go for the strong reductant. So there is a possible to measure the relative strengths of various oxidants and reductants. And another one, we can easily possible to calculate the standard cell potentials. When we know that standard electrode potentials, standard zinc electrode potential, when we know that standard zinc electrode potential and standard silver electrode potential and standard copper electrode potential, then when you can measure easily the cell potential of electrochemical cell. That is another advantage. And third one, reactions, there is possible to predict the what type of reactions. Oxidation reaction it takes place, or reduction reaction it takes place. Element, how it going to move in electrochemical cell, then we can identify it, then we can predict that reaction using of this standard electrode potential. The possible reactions, so we can predict, there is a possible to predict the reactions. That is the advantage. And another advantage, the prediction of equilibrium in the reaction, equilibrium state. So how the equilibrium state of that particular reaction, there is a possible to prediction. So we can identify it. So that is the advantage of uses of standard electrode potential. What are the limitations of standard electrode potential? So we know that there is so many advantages is there. So standard electrode potentials, but what are the limitations? Only there is a possible to predict the reaction, what type of reaction is happened in the electrochemical cell. But we cannot predict using the standard electrode potentials, so rate of the reaction of that electrolyte solution. I mean, rate of the reaction, there is not possible, we cannot predict the rate of the reaction by using standard electrode potential. We cannot determine rate of the electrochemical reaction. I mean, electrolysis process in the electrochemical cell. It is very difficult to predict that rate of the reaction of the electrolyte. So that is the disadvantage of, limitation of the standard electrode potentials. But standard electrode potential to give the more information about the various electrode potentials. So that is the main advantage of this standard electrode potentials. There is another advantage. We can go to measure the electrochemical series. We can identify the electrochemical series. In the electrochemical series, we can identify which is a strong oxidant, which is a strong reductant using these standard electrode potentials. Now, we are going to discuss what is electrochemical series. What is electrochemical series? Electrochemical series is nothing but electromotive series. We are also called as the electromotive series. Then we can say that this is activity series. Activity means it is a concentration. Activity means it is a concentration. So this is the activity series. We also call as the activity series and electrochemical series and the electromotive series. What is activity series? What is electrochemical series? We know that each and every metal or non-metal have some specific potentials. So metals and non-metals have some specific potentials. It generated some specific potentials at standard conditions. At standard conditions, when we are going to measure the potential of that metals and non-metals, the potentials we are going to arrange in increasing order. When we are going to arrange the electrode potentials in increasing order of the standard reduction potential values, based on the standard reduction potential values, that is called as a electrochemical series. Electrochemical series, it is nothing but the arrangement of electrodes in increasing order of the reduction potential values is called as a electrochemical series or activity series or electromotive series. Electrochemical series or activity series or electromotive series. Then we can say also the arrangement of different electrode potentials of different electrodes from highest value to negative value to positive values. So when we are going to arrange the potential, electrode potentials, so negative potential to positive potentials, that also called as a electrochemical series. Electrochemical series is nothing but we are going to arrange the electrode potentials in increasing order. The potential order, increasing order. When we are arranging the increasing order, so either metals or non-metals, so from negative potential to positive potential, so that is called as a electrochemical series. So in the electrochemical series, we are utilized standard potential. One of the reference electrode. So that reference electrode is standard hydrogen electrode. So different electrodes we are finding the potential, different electrode potential we are finding using the standard hydrogen electrode. The standard hydrogen electrode to give the standard potential. That potential is the electrode potential of hydrogen is 0 volts. So we are using 0 volts of standard hydrogen electrode because how we are going to measure the standard electrode potential? There is two cells is there. So one is hydrogen electrode and another one is hydrogen electrode and another one is that is a zinc electrode or metal or non-metal electrode. So then using of this hydrogen electrode always it can generate the potential value that is 0 volts. So that is 0 volts. So then using the standard electrode potential value, the electrode potential value, we are going to measure the another electrode potential value. So that is the electrochemical series. So in the electrochemical series, we are using reduction potential of metals and non-metals using of this hydrogen electrode. So the metals with higher negative potentials are stronger reducing agents. So when the metals have higher negative potentials, so that potentials, metals or non-metals act as a stronger reducing agents. And when the metals or non-metals, so higher positive values, higher positive potentials, the positive reduction potentials, they act as a stronger oxidizing agent. So higher negative potential of elements or metals or non-metals act as the stronger reducing agents, and higher positive potentials, reduction potential of metals or non-metals act as a stronger oxidizing agent. Similarly, the metals with higher negative potential, negative reduction potentials, higher negative reduction potentials, the metals, so which are metals have with higher negative potentials, it displaces a metals with lower negative potentials of metals. So it can easily replacement of metals. We are utilizing the potential based on the potential values. Which metal is going to replace the another metal, we can easily identify it using of these reduction potentials. So this is electrochemical series. Electrochemical series is nothing but the arrangement of electrode in increasing order with their respect to reduction potential values. So that is called as a electrochemical series or activity series or electromotive series. We are going to measure the electromotive series, electrochemical series, their potential, reduction potentials using hydrogen electrode, because hydrogen electrode is it can generate always zero potentials. So that's the reason. So hydrogen, based on the reference electrode, based on the hydrogen reference electrode, we are going to measure the potential of different various metallic and non-metallic electrodes. Then we are going to arrange the increasing order. If you look at that table, so there is a figure, there is a different metals, their reduction potentials. So the different metals and their reduction potentials. So fluorine, to gain the electrons, all are reduction potential. At standard conditions, the metals are non-metals, it's going to displace the reduction potentials. So the fluorine have the plus 2.87 potential, the plus 2.87 voltage. The potential is the reduction potential of fluorine. The reduction potential of fluorine is the plus 2.87 volts. That means the fluorine, to gain the electrons, to convert it to F, fluorine. The fluorine F2, to gain the electrons, to gain the 2 electrons, it is converted to 2F. In aqueous solution, then the potential, the reduction potential is the gain of electrons. It is called as a reduction. That reduction potential is 2.87. Because based on the reduction potential, we are going to arrange the order. That is called as the electrochemical series, based on the reduction potentials. And highest, the fluorine, to displace highest positive potential, that is 2.87. Similarly, the lithium, it displays after gain the electrons, lithium plus ion, to gain the electron, it's converted to lithium solid. The potential is minus 0.34 volts, minus 0.34 volts. So this is highest negative potential of the metal, negative potential or reduction potential of metal. Lithium displays, it shows highest negative potential of reduction potential, that is minus 0.34 volts. If you look at there, if another metal, there is a hydrogen displays, hydrogen reduction potential is H plus ions, to gain the electrons, to convert it to 0. It converted to hydrogen, the potential is 0. So the H plus ions to gain the electrons to convert it to hydrogen. So that potential displays the potential is 0 volts. So utilizing this hydrogen electrode, we are going to measure the remaining metal and non-metal reduction potentials. So we are taking reference reduction potential of this hydrogen, and we are going to measure the different electrode, various elements, various metal and non-metal, so reduction potentials. So look at that, potential is going to decreasing here. So plus 2.872 minus 3.04. So when it's going to decrease, the potential is going to decrease. So the reducing capacity is going to decrease. I mean, it's going to increase. I mean, stronger reducing agent. It means it's act as a stronger reducing agent. I mean, the capacity of reducing is going to increase. The capacity of reducing is going to increase. So, I mean, the fluorine it act as a weaker reducing agent. The fluorine it act as a weaker reducing agent, and the lithium act as a stronger reducing agent. The fluorine act as a weaker reducing agent. Lithium act as a stronger reducing agent. Similarly, the fluorine is also act as a, it means the fluorine is act as a stronger oxidizing agent, and lithium is act as a weaker oxidizing agent. Lithium is act as a weaker oxidizing agent. We can easily predict which metal, which element is act as a stronger reducing agent and weaker reducing agent, which metal is act as a stronger oxidizing agent and weaker oxidizing agent, using of these standard reduction potentials. So if you look at the potentials, so we know that, for example, voltaic cell, the potential is zinc, the reduction potential of zinc, that is minus 7.06, minus 0.76, and the potential of copper is that is copper to gain the electrons, the potential is plus 0.34 volts. Plus 0.34 volts. The reduction potential of zinc is minus 0.76. The fluorine it shows is displays 2.87 volts. It means it is act as a stronger oxidizing agent. Lithium it act as a stronger reducing agent. Lithium, it displays the reduction potential is minus 0.34 volts. It's act as a stronger reducing agent. So this is the arrangement based on the reduction potential of some metals and non-metals. So this arrangement is called as a electrochemical series or activity series or electromotive series. For example, in electrochemical cell, in voltaic cell, the potential of copper is 0.34. The reduction potential of copper is 0.34, and the reduction potential of zinc is minus 0.76 volts. So based on the potential values, we can predict which is going to, in the presence of these two electrolyte solution, in the presence of two electrodes, which is going to oxidation takes place, which is the reduction takes place. So minus 0.76, but the potential is reducing, stronger reducing agent, because zinc is reduced to the copper. So that's why, copper is act as a, at the electrode, the copper electrode, it act as an anode, and copper electrode is act as a cathode, and zinc electrode is act as a anode. Due to the reason of the potential, we can easily identify which is going to reducing the another metal. So the potential based on the potential values. So this is the electrochemical series and activity series and electromotive series. They're also called as a electromotive series. And we can look at that. So what is the applications of electrochemical series? We can look once again, what is the applications of electrochemical series? The first one, we can easily identify the comparison of relative oxidizing and reducing power. Relative oxidizing, which is greater oxidizing agent, which is the greater reducing agent, which is a more oxidizing power agent reagent, which is a less oxidizing power. We can easily identify using this electrochemical series. Electrode potential, standard electrode potentials. With the standard reduction potential, we can easily identify which is the strong reducing agent and which is the strong oxidizing agent. For example, so the iron, the potential is minus 0.41 volts, Fe2 plus. The Fe2 plus minus 0.41 volts. The reduction potential is minus 0.41 volts. So the lithium potential is minus 3.04 volts. The lithium potential is minus 3.04 volts. So lithium displays minus 3.04 volts. So that means the reduction potential is higher than the iron reduction potential is higher than the lithium potential. Therefore, iron easily reduced and the lithium ion is easily oxidized. Iron is going to easily reduced and the lithium ion is going to oxidized. So we can easily identify it based on the potential values, which is the more oxidizing power and reducing power. And another one, the relative reactivity of metals, the reactivity nature of the metals, we can identify using of this electrochemical series. Another application, the reactivity of metals. So for example, if you look at the zinc potential is the reduction potential minus 0.76 volts. The copper potential is 0.34 volts. Therefore, that's why zinc is always replaced to copper. It's replaced to copper from an aqueous solution. This is a simple reaction. Zinc, when reacted with zinc with copper sulfate solution, then zinc to replace the copper to form zinc sulfate solution. To replace the copper, it forms zinc sulfate solution. Then that's the reactivity. We will find out the reactivity of metals in the solution, in the mixed solution. So in the binary solution. So that is the advantage of electrochemical series. And another application, that is the spontaneity of reaction. So another advantage is spontaneity of reaction. When we know that when we identified M of the cell potential, the cell potential is a negative. So then if we can say that is the reaction is a non-spontaneous reaction. Non-spontaneous reaction. So non-spontaneous redox reaction takes place in the electrochemical cell. So based on the negative, the cell potential is negative, then the redox reaction is non-spontaneous. If the cell potential, EM of the cell potential is positive, then the redox reaction is spontaneous redox reaction. So the potential, EM of the cell potential were identified. So spontaneity of reaction. So what type of reaction, what type of cell potential is generated in the electrochemical cell were identified using of that electrochemical standard reduction potential, electrochemical series. The spontaneity of reaction were identified using this standard reduction potentials, electrochemical. Another advantage, another application of electrochemical series, the reactivity of metals. The reactivity of metals. We know that the activity means the concentration. The activity of the metal depends on its tendency to the loss of electron, lose the electron. That is, it tends to form when electron to lose the electron, when the metal to lose the electron, to lose the electron is converted to Mn plus. It is a positive cation it can form. This tendency depends on the magnitude of standard reduction potential. That is called as a standard reduction potentials. So from that, we can easily identify reactivity of metals. If you see, there is some metals is there, iron, lead, tin, nickel, cobalt, etc. So these metals are quite down in the electrochemical series, a little down in the electrochemical series. Do not react with, these metals do not react with cold water. but it can react with steam or steam water, and it can evolve the hydrogen. It can easily evaluate the hydrogen. But these metals, it cannot reacted with cold water, but it can reacted with steam at steam condition at a higher temperature, and it can evaluate the hydrogen evaluation. It can takes place. The reactivity of metals we can find out using of this electrochemical series. If you look at the another metals, there is a copper, silver, and aurium. Copper, silver, and aurium. So which is the lie between the hydrogen, less reactive, because in the electrochemical series, and it is very less reactive with the water, hydrogen, and do not evolve the water. That is the reason. So these metals, copper, silver, and aurium, which lie below the hydrogen, are less reactive and do not evolve hydrogen from water. But these another metals, it is aimed to evolve the hydrogen. The reactivity capability we are going to find out using the electrochemical series. Another important application, the electropositive character of metals. Electropositive character of metals. So the electropositive character is also depends on the tendency of loss of electrons. So that's the reason. So when the electropositive character of metal decreases from top to down, bottom in the electrochemical series. So it is the characteristics based on the reactivity, if you look at that electrochemical series, the electropositive character is going to decrease. So from top to bottom in the electrochemical series. So we are going to identify the electropositive character using of this electrochemical series. For example, strong electropositive metals. If you look at that electrochemical series, so the potentials, the reduction potentials, minus 2.0 volts. The reduction potential minus 2.0 volts are more negative potentials, more than minus 2.0. So like alkaline earth metals are very strongly electropositive nature metals. So which metals to display the reduction potentials minus 2.0 volts or more than minus 2.0 volts, then that potentials based on that potential we are identified that metals are strong electropositive metals. If you moderate the electropositive metals, it means potential 0 to minus 2.0 volts. In between that 0 and minus in electrochemical series, so 0 to minus 2.0 volts. So that metals, it's act as a moderate electropositive metals. For example, aluminium, zinc, iron, nickel, cobalt, etc. These metals are moderate electropositive metals because in the electrochemical series, their reduction potentials lies between the 0 to minus 2.0 volts. If more than minus 2.0 volts, we are called as a strongly electropositive metals. So when the 0 to minus 2.0 volts, in between that range of reduction potentials, that metals are moderate electropositive metals. So another metals are weakly electropositive metals. So below hydrogen and the positive values of reduction potentials is there. The positive reduction potential, if identified, the electrode potential is identified, that metals are so very weakly electropositive metals. It displays weak electropositive metals. So then the characteristics of metals, so which is going to more electropositive, which is going to less electropositive, we can easily identify using of this electrochemical series. These are the applications. So now in this session we are completed. So what is electromotive force and how we are advantage of electromotive force to calculate the electrochemical cell potential, and we are also discussed the electrode potential and what is a standard electrode potential, what is a standard reduction potential, and what is standard oxidation potential, and what is how we are going to measure the standard EM of the cell, and electrochemical series, and what is the applications of electrochemical series we are discussed in this session. And thank you very much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.